Alrighty, those were the three cases of sines and cosines. We are next going to talk about square roots. Yes, indeedy, square roots. So, helpful hint about some of these problems. For example, cosine squared can be transferred into the double angle formula. Also, you could multiply both sides by 2, and 2, whoopsie, 2 could be multiplied to cosine 2 theta, thus making 2 cosine squared theta is equal to 1 plus cosine of 2 theta. Or, yeah, that's what we're going to use. There's also sine squared theta. You could also use, that. But anyways, so for this particular problem, this is what we're going to use. Also notice that there are bounds now, so you're going to have to do all of that lovely math work at the end. Okay, so the first thing about this that you need to remember is that this is not 2 theta, it is 4x. So that is 2x's right there. So the double angle, the theta part of it would be the 2x, okay? So as you use that 2 cosine squared formula, don't forget that the theta is 2x. Okay, so I'm going to take this and I am going to then transfer it into so because that's 2x, you can see that this right here is the formula for double angle. So we can then transfer that into my 2 cosine squared as the formula up here shows us. Okay, so now we can actually split this up and put your square root of 2 as a constant on the outside, and the square root of cosine squared is cosine. Don't forget that when we square root, because the inside needs to stay positive so that this stays in the real numbers, we put officially absolute values around it. But then I see that I have this going from 0 to pi over 4. So because that 0 to pi over 4 interval is positive, we don't really need the absolute values. And now I can integrate my cosine. Into sine. Okay, so go to the next slide and try the problem. And if you have any issues, you can come back to this slide, pull up the video again, and you'll be able to see the problem done out on this video.